On there, and it already like freaked some kids out.
For the new
quarter. I gave them
for the new kids that you just left.
No, not that for like the kids I have already.
Oh, okay.
Because I gave them we did quadrilateral properties.
Mm-hmm.
So I gave them the one where they had to like identify what the quadrilateral was based on how it was marked.
Mm-hmm.
And I did that for all of my sections, and most of the kids did it already, but it scared the ones who didn't. So since yesterday when I screen captured 43,000 or 45,000.
Wow. So then more practice.
Some of them were doing more. Some of them did the wrong eye though.
Oh, yeah, that's the one.
Which happens all the time, I feel like. Like what you didn't even do one in the right section. Like
I like usually put it right big on the screen.
I put it big on the screen too. I put it on Classroom. I put it everywhere. So and they still do the wrong.
Or sometimes like
I think you might have to lock out, I think. Maybe. I think once it's
not the other.
Hi, you guys. Can you hear me?
Hi, we can hear you.
Oh,
Yes.
great.
Great.
Can you hear us?
Yes, perfectly.
Assuming so.
I can hear Nantucket too.
Professional.
So what are you doing the rest of the time? Oh yeah. Hey Sarah, we had a question.
Yes.
That last session, is that when we took the test?
I don't know the answer to that. Did you already took it, right, Ton?
We took the pre-test.
Yeah. So the post-test.
We haven't done.
We haven't done.
You guys, Nantucket, you guys didn't do the pre-test?
Oh, we did the pre-test,
but
not the post-test.
Yes. The post-test, I have no idea when you will be doing that, but I will write to Matt right now.
Okay.
When did you do the pre-test?
When did we do the pre-test?
Mm-hmm.
I mean, before the first session. Yeah, like September sometime, I think. Whenever, like a week before the deadline.
I see. I don't think so. I think it will probably get mailed to you or something like that.
Yeah.
Like the last time too.
Yeah. So it might, I'll see what I can find out. So I think New York is going to be here, but I can't quite tell from what I sent. It may be just you guys. They may be doing this makeup on May 2nd. Okay, so why don't we just get started? I think they're making this up. I think it's just you guys. So You can get started on the opener, and I will let you know what I hear from Matt.
Awesome. Thank you.
You push back to come up with,
How long is your parenting today?
3, sir.
What's that?
3.
You guys do 7 please.
I'll put it on the wall. Okay.
I can come before that. It's like all. We done this?
Not 50.
Not 50.
The-
We just done similar style.
Yeah.
Platforms.
This one, they give like album, which is a factor of 50.
So these must do stuff.
But I'm trying something else. I'm trying like take one of the complex number factor of 5 and then pick one from 10 and then like multiply that.
So
Together.
Yeah, and then one and you can have a different combo of 7 and
7 and 1.
yeah.
and then you come back in September.
You gotta take September and October. We're planning to come back. I think back in 6 months, back with insurance. But we also have we're gonna pay through this whole time, so
Pay what?
we're gonna do office leaving. We have a contractor there. Probably gonna. I may go back earlier. I don't know. I think it's
I'm getting sick. Like, I'm going to go on vacation.
Okay.
That would be fun.
Sometimes
How's it going?
Keep on going. Yeah, it's up area.
Sometimes it happens. 6. Do you get something? You're gonna.
Well, we have to do the same kind of thing for the norm. We do the number that's conjugate.
Yeah, it's like if you go like this, this.
Starting.
So if we multiply them together, we'll see what we get. So we
Yeah.
did 2 plus I times, say, 3 plus I. Give us
I mean, this, these two are related,
plus 2 plus
right?
plus I squared.
Like
So that'd be 5 plus 5I. Oh yeah, that's gonna give us 50.
Where like we can use these to.
yeah, I got 5 plus 5. And then I
And that will give us 50.
yeah.
25 and 25.
And I got like the 7 and 1 that you got over there.
Mhm.
So I
Oh, you
wonder.
did. Oh, and you did the other.
Yeah, I got 1 positive, 1 negative. I wonder if
Mhm.
we're gonna do
So
something.
if we did negative, if we did the 2 minus I times 3 plus I.
Yeah.
Yeah.
What's the? I'm gonna do the. Yeah. Let me do that.
49, 7 and 1, right? 7 minus
Yes,
Why do you say that?
It's gonna be a 7.
this can be 7.
A combo.
7 minus I.
the conjugate.
Oh, you did 1 plus 1 minus?
I did 2 minus I and 3 plus I.
Oh, okay. Oh, I'm
I mean, there's multiple.
with minus. Let's see. It could be end up being just a 5 and 5.
But maybe it won't be different sign or something.
Yeah. Any combo?
So if the sign, it looks like if you pick the ones where the signs were
The herder.
the fives, when you pick the ones where the signs are different, you get.
Are we starting, Sarah?
Yeah,
the
it's just a-
seven.
Oh, I'm sorry.
Yeah,
She's coming right.
we're started.
She said
I
she'd
think
be coming around.
Chicago has started, right?
Yeah.
Totally. Right.
If we were to grab that, I guess they're saying, right?
All right, Casey has started.
Like, we know we're gonna get a circle, right? Because that's what we want.
So you're saying that like we
How
have
are you guys writing that
the 7%?
Yeah, but through, from this way, I guess we're gonna get
fancy end though, doesn't it? It's like a
So-
because we get the,
It's a special fun.
like with each of these, so like with the seven, yeah, you have 8 coming.
No, because I
Then
can't.
the 5 and the 5, you get here too. 4, I think you only get 4, right? Because they're the same number,
Oh, so you can swap it that way.
so you only get 5 plus
Yeah, wait. Yeah, you have 4 to pick from.
We should have somehow use these, right?
I think it's just because the 5 is in both spots.
So
Yeah, sure, 7 is one. Sure, 7 is fine. I feel like we're supposed to be able to use these.
Also use those. Like,
To put them together.
yeah, right? Shouldn't that equal? Let's try.
How do you do it? And then the complex plane we talked about last week was kind of similar to like mod 4.
yeah, I asked a question, what's an XY? And I bring out an SDT problem. And then in the tag, it says, in the XY plane, blah, 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 blah. And then like,
Similar, but that's
I bring
not
it down.
last time.
What do you think is an XY plane? That's weird. What is it? It's like,
What was it? Today we were doing waves, and we were given what the 2 tops of the waves were, and I wanted to get then the distance to like the next crest of the wave. So like we had to just find the difference between the 2, and then
Yeah.
add that to like today they're like acting like I'm supposed to do crazy stuff.
just like the distance.
The amount of kids that said, how do I do the bit or put a fraction in the calculator?
I'm doing that. We talk about it. 2, 3, 4, 5.
I don't think we get any more whole numbers besides this, right?
Yeah, I don't know because they keep playing with 2 and
It's not like 3, 4, 5.
Just gonna end up with the same thing.
well, besides 5 and 10, well, 25 and
It's all in
I don't know. Were we able to get a norm of, oh yeah, I plus 1,
5.
and a norm of 2.
Okay,
So it has to be like
plus 1, and then the other.
I plus 1 and 25, so it would be 5. 5 and then or negative 5, like 5 minus 0.
Yeah.
Right?
Oh, because of yes. So wait, that's right.
So I'll just give us 5 0. 5I plus 5 1.
Oh,
You did like
okay.
I plus 1 times 5 minus 0 I or something.
Oh, yeah. Even if you put the then you just switch the I to the other 5. Okay.
So it's 5I minus 0, I guess. You see a 5i squared, which is negative 5i. No, negative 5. And then plus 5i. So we just get the same thing.
Same.
And that's all. Those are the only factors of 50.
You guys,
Yeah.
Ton and Yuyan,
Yes.
I put the link to the Google Doc
Yep.
into the side of this broadcast. So if you guys, as you're doing things, I think it's actually really useful to record them into that shared spreadsheet.
Sarah, where is this link?
Do you see the link? There's like group chat. Do you see that little do you see that little blue chat bubble?
Ooh, chat bubble.
No.
No.
I have full screen right now.
Okay, let me just email it to you. How's that?
Yeah.
It's the same link as always, but I know it can take a little while to find.
Sarah, what tab do you want us to use? The shared space, workspace.
You're pretty far away from the microphone, right?
Sarah, what tab should I use?
There are a lot of choices, but I would say shared space.
Shared workspace. Okay. And
Or table leader check-in. I don't know.
yeah.
What do you guys think? We've kind of used everything.
Should we just go to each section and just continue from go to the one that without names?
Can you make a copy of the table leader check-in and make it for set 7?
So what I've been doing, Yuyan, with yours is copying them into the table leader check-in.
Okay.
So we don't have to do that. You could also just work in your spaces. It's up to you. Just as long as I know where you are, it's actually really helpful to see those updates.
Okay.
So Yuyan is working in the Nantucket worksheet.
Okay.
Ton, what's your preference?
We'll work on the Blaine.
Okay.
So what do you guys? How are you guys doing?
We found 12.
Yeah.
We found 12
I was just kind of getting into it, but
complex numbers that form the circle when we graph them in the column.
So what are your coordinate pairs for the complex plane? 7, 1, and then
-7. Right, all of the.
Factors.
7, 1, 7, -1. Get what?
You graph the
Yeah.
So the vertical is the
Complex axis.
seems like it's all.
Anything else?
What about like 1 and 7?
Mm-hmm.
Yeah.
Right? All of those.
Yeah. Right.
Just doesn't that would be that would be
What doesn't work?
Or maybe they want us to use it.
Oh, right, because you do
Oh.
49 plus 4.
What? Important stuff.
I need to do my professional practice goal all tonight. This is the way I wrote it.
Oh, because of the reflection.
Mm-hmm.
You
So
don't have
how
to.
many weeks of it? 10. I'm just gonna do it from the start of like Q3 maybe.
You don't have to.
You know,
No, I'm just gonna put like, I'm gonna do like 2 bullets for each. I'm not gonna go nearly in depth as I did already.
We reflect every day. Like I was trying to teach about special triangle, and then I go back the next day and same thing because the first thing didn't work.
So how many pairs did you guys come up with?
Last year I did like graphical proofs and else, but I don't think we'll do that this year, just for time.
Yeah.
Or it could be my way of reviewing graphing, like my reasoning, so it's not just like shoot out. Because we'd have to review slope and longer theft and distance formula at that point.
Mhm.
I think it makes it a lot more intriguing. Like here's a quadrilaterals graph to prove it's a parallelogram. So I would just make them prove like opposite sides are parallel.
I think that could be a good connection.
But then you get the slopes and then if I said prove it's a rectangle, then they have to get used to proving it like perpendicular slope.
You always grab stuff. I'm just like, John.
It makes a lot of sense to me. Oh, so it's probably going to make it circles.
We have to show that the.
Ton, did you get that conjecture? This is probably going to make a circle. I think it's worth putting in the Blaine notes. Why do you think that, you guys, by the way?
As I'm graphing it, I'm seeing a lot of
Okay, good.
The radius of the circle,
I don't know yet. I have to
square
graph
root
it.
50, right?
Yeah. Because of the different.
Well, I mean, all of them, they probably don't have the
Square pi,
is the-
so that has to give us the radius,
Yeah.
because if you undo your head,
if they're triangles.
it should be, radius should be
All the
square root.
triangles would be square root of 53.
Or no, diameter. Yeah, because that's our square. X square.
So you kind of like did an approximation of square root of
These
50.
are all right.
With that circle, yeah.
With that, I think so.
Square root of 50. That's why I thought that was like this.
Yeah, that's a little more intense.
But I'm not sure yet.
What about your 7, -1 though? Like
Right, 'cause they're gonna
7,
be-
-1?
Mm-hmm.
That kind of looks like, I mean, they're like really,
Like,
Yeah.
They're all just
they're
gonna
like,
start unit circle.
I think there would still be a curve, it just going to.
Well, what would hit 0? Like-
that curve is interesting.
Well, but, right, but then it would
What a
just be
compass.
outside.
Yeah.
Square root 50 is a
Well,
little
'cause
7.
Yeah, because it's
So close, so it's not gonna go exactly to 0.
It's for just more than 7.
It's so.
What's the radius?
Hold up, I'm gonna do it. I'm gonna figure it out.
That's what it looks like.
I think I figured it out.
So this is X.
It- If I is 0, or if y is 0, right? Then x would have to be
Square.
And we have to
which is
expression goes to the norm.
Yeah, the norm you take
is
for x and your y.
So we just need to figure out how to do something.
So yeah, like basically how we calculate the norm is using
Well,
I
visually.
guess we can just do like
like
measure the
how we write the equation.
sex, right?
Equal that. Yeah. Our, yeah.
I mean, it's not perfect. It's not perfect.
So it's the equation of a circle, 7 that the
But these are the only integer values of x and y.
the radius equal to the square root of norm or something like that.
Circle isn't perfect.
How did you make your circle? How did you get there?
Square root.
How did you figure out the distance between your point and pencil? Just did it between one. Yeah.
So it's an approximation.
Because mine's pretty good.
There's some ones that we can get like multiple ways, like 85, I think we can get multiple ways.
Like,
If we had that, like we would just get more points on our circle.
oh, did we do 85 before?
I don't know if we've done it, I think we get 85 multiple ways. And then we get 7 squared plus 6 squared. Which we think else. Not anything.
No.
Then,
But we've done 85 one way, I meant like.
or maybe if we can do
At
5,
85, you can only do one way.
but what if we can do 5 more than one way? Can we do 5? No.
I think 5 is the only way we can. And 10, that's the only way we can do 10.
So did you guys get anything else other than
Yeah.
4 and 9?
The way we can 10.
No. No, this was like,
Oh, 17 is like.
yeah, I feel like we're not really getting those number facts though, right?
And 16.
There's a relationship or something.
Or
So if you guys look at the opener, like those number facts in the beginning, like we're not really using those. We're just kind of coming up with
something.
Yeah, I mean, something we did last time, like, if this is 5 and this is 10.
Yeah, 17.
we use Find 50 back.
Well, add them. 2
X
plus
squared
3
plus
plus
y
5. And 5 doubled is
Well, x squared plus y
It's
squared is
10.
gonna equal
where?
4.
Yeah, someone have more. So you're trying to find like one unknown that has more.
You guys feel like we're using those 4 number facts?
I did to get 7.
How?
I felt like I knew that 3 squared was 9, and it was just 9 plus 1. So that's how.
75.
Because like 100, you can definitely get multiple.
I'll say that again.
That can be 10 squared.
Mhm.
That can be,
The
you can do 36. and
conjugate
60.
of plus,
And then you can do even 10. I mean, not the normal.
right? So you take the 2, you square the 2, and you add 1 to it. So then you square the 3, and you add 1.
100.
I was thinking,
But if it's
what
like 10 and then
Close
close
to
to 50.
that's a square?
You said
59 plus 1. So like
2.
50 subtracted 1.
Well, with 3 plus 9.
Oh, okay, 7.
20.
So that's why I knew it was 7 plus I. 7 minus 1.
Maybe it's like 100 has more.
So you're saying you're using the y value of this. You're using the y value here.
So I took, so if you do minus 1, you end up with a perfect square. And that perfect square root of that happens to be that.
Are there any other polynomials that we have?
Even if you just used a graph and you like try to test.
Yeah, and the closest one I got was 6 4 and 6
So like
4.
three different unique sections. Right.
Yeah, I think
So-
we've only ever gotten 2.
Yeah. But like that.
I'm sure that, I mean, I'm sure once the numbers get larger, you can probably get more ways.
What do you guys think about the equation x squared plus y squared equals 50?
You have it on the paper.
Is that the equation of the circle?
That's what I thought. That would mean this, which means that x plus y equals square root of 50, which is what Jen said. Forever. I'm catching up now. Yes. Yeah, because you were better with the graphs, I think.
I need anything visual.
Oh,
I don't. I was like,
there's no more, right?
It looks so nice.
I don't know. Sarah's not saying go on. Are you guys going on? All right, let's go on.
Did we write all of the notices and wonderings?
Oh, wonderings. Yeah. Do you have some? Chicago, do you guys want to stop and talk about the opener?
Yeah, I'd love to.
Okay. And how about you, Nantucket? Is Yuyan there? I can't.
Yeah, she was just typing, so.
Oh, yeah, great. Okay, so Chicago, what did you see?
We made a circle with the plots that we pointed on the complex plane.
Mm-hmm.
We found that 7 and I worked, and then the, like -7, -I, blah, 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 all those variations of it, and then also 5 and 5, so 5 plus 5i, and then -5, etc. And so it created a circle, and it looks like the radius would be square root of 50.
What do you guys think? Oh, Yuyan is nodding. Great.
Yes.
Yeah, we agree.
Mm-hmm.
You agree. Anything surprise you or any wonderings that you have?
Yeah, Darren have one of them.
So we started trying to think of, it feels like a lot of the numbers we worked with our norms in a couple sessions. We've had like 2 unique sets of numbers, and we're trying to see, from maybe that first list of the x squared plus y squared we did way back in like session 2. We were trying to think back, were there any of those that we could have had 3 unique sets of numbers, which we haven't been able to find yet. So there's some out there, we just haven't gotten it.
Chicago, do you know what they mean? Do you want to ask? What do you guys want to say more about what you mean by 2 unique sets of numbers?
Yeah, so like for 50, for example, we were able to get the set that included 7 and 1 and 5 and 5. And we're trying to think, are there some numbers out there where we can get even a third set of digits that are unique with 4? So
Okay. Yeah, I think we agree. If you guys have 12 coordinate pairs altogether, right?
we can 12 altogether. For example, there should be one with 24, for example.
What do you guys feel like you use those number facts those 4 number facts to help me in any way? Like I'm really confused about how the problem is working. Like it says use those number facts to come up with the integer pairs. And I felt like I couldn't use those.
Yeah, when we jumped and we tried, like, we took 2 plus I and 3 plus I and multiplied them together. And then we just started doing combinations of those. And that's how we got the set here.
Okay. Like, I don't know, just like doing 2 plus I and then 2 minus I, like that, to get 7 plus 1.
Yeah.
And then 7 minus 1. Yeah, like that, I guess. We were trying to figure out like, well, like 5 times 10 is 50.
Yeah.
Right? So, but like, how do you, and then I wrote out like the norm of 2 plus I times the norm of 3 plus I should give you 50. And I did all that work. And it does equal 50. But like, I didn't, did I? No, like it.
That's because 5.
I mean, I guess it kind of does because you end up getting like 36 plus 13 plus 1 equals 50. And then 36 plus 13 is 49. So you get the 7 and the 1, I guess. I don't know.
Yeah,
Nantucket, do you want to say something about how you did it?
yeah, we kind of did what you said, that you pick one factor from the complex, for the complex, I don't know, of 5, like the 2 plus I, and then the 3 plus I, but we don't find the norm yet. We can multiply them together first, and then we got the combo of 5 plus 5I, and then we find the norm and verify that it's equal to 50. So we're using those factor up there in the number facts to kind of find different combos, but then it kind of it repeats itself within the 2 unique sets, the 7 plus I and the 5 plus 5I.
Okay.
When you were finding when you were picking the 2 factor from the number set, do you kind of jump straight into finding the norm, or do you multiply those 2 factor out first and then look at them before you find the norm? I'm just curious. That's all.
Like I just look for perfect squares, like how to compose 50 as a sum of perfect squares.
Okay, but you talked about earlier you were multiplying to find the norm. Are you gonna jump? I don't know, straight into. Never mind. Yeah, that is probably.
Yuyan, you guys, every time you talk, I don't know, Chicago, do you see them as a blur?
Yeah, they kind of break up. They get pixelated. But
Oh, sorry.
No, it's not. I don't know why it happens.
Our weather here.
No, I think it only happens when you talk. The rest of the time, it's fine. Do you want to ask one more time? I think, are you asking about the order? Like, did you find the product first or the norm first?
Yeah,
I think this one for us.
yeah, that's what I'm trying to ask.
you guys understand the question?
No.
I'm not clear on the question. Casey and I are not clear on the question.
Oh, when you were looking at do you guys get a chance to play with the number fact, like those complex number, in the number fact section?
Yeah.
So when you like pick those number and play around with it, did you like find the norm first, or you find their product first?
Yeah.
Which she's saying, which one did you do? Did you find the norm of those numbers first, or did you find the norm of the? Did you first find the product and then find the norm? Do you-
Ariel said she did the norm first.
Okay. Maybe if you guys find the product
First.
you see some related to the 7i and the 5 plus 5i.
You guys want to?
You mean the product of the norm of 2 plus I and the norm of 3 plus I?
Yeah, not the norm. Do the product first. Do the product of 2 plus I and 3 plus I.
I'm sorry, the product of, say that again,
2
Yuya?
plus I and 3 plus I.
2 plus
Yes.
Ah, okay.
Oh, yeah.
Interesting. That gives you the 5 and 5, right?
Yeah, but then
The plus, if you make them both plus.
Multiply another 2 together.
Use 1 minus 1 plus.
Ah, yeah. Thank you, Yuan.
but that's a really long time.
That's
I mean, I think we learned this last
Yes, we
week.
did.
Asking, I'm like, I know these.
Yeah, okay, thank you.
Okay. Any other wonderings or anything else on your mind?
Yes.
Yes. Oh, Yuyan, do you have a wondering?
No, we just Darren talk about the 2 unique sets. We want to see if there's more than 2. If
Okay.
there's a number.
Yeah, I think that is a good idea. That's great. And but do make sure at some point that you do get to the first couple of important stuff things too.
Okay.
You can keep going on your search for 3, your set of 3, but don't forget important stuff because it is important today.
What was your wondering though? You're thinking there's more?
Not for 50. Maybe like Darren said that. Go ahead.
Yeah, like that maybe there's a norm out there where we can get 3 unique sets instead of just 2. So like this one, we had all the combos of 7 and 1 and 5 and 5. So we're trying to see, is there a number out there where we can get 3 unique sets of perfect squares added together to get it?
Cool.
So far, the ones we've been listing, we've only got 2 at max. So we're trying to figure out another that's out there.
The truth is out there.
I'm sure it's out there, but
Okay. Important stuff number 1.
I love the quadratic formula.
Yeah. Find 3 solution to the equation.
You know, one of them is just for z cubed equaling 1.
Oh, can you do the
I think we
quadratic?
kind of did this a little bit last time.
Yeah.
So we know one of the solutions for b. So for b, one of the solutions has to be z minus 1 equals 0.
Yes.
So z equals
Mhm.
then the other 2, z squared plus d plus 1. We'd have to use a quadratic formula for that one. One plus or minus just gonna give us this. Well, that'll be one of them.
You want to see that I didn't. You're fast. You got.
Also, z is -1 minus I.
It's hard to
2.
grab this one because now you have to
And you have your,
pick out like decimal.
yeah. Those are all your zeros. So your F value will be 0 at all the 3.
The X.
Oh, no, not X. Like,
Um,
your Y's are 0. Because those are your X values.
yeah, but then they want to graph the. Are we graphing like in the 3D world, like X, Y, and Z, or just graphing?
Oh, yeah. Or are we just
graph-
graphing as if it was cubed?
How do you do 1A?
Not sure.
I do.
imaginary part of
We don't have.
So like area model?
of just X.
Which is the
Yes.
same thing as the area.
Yes. Yeah.
Of the 3 solutions of the same complex. Do we have is there an imaginary complex plane too? Or
And then
third, I guess, or.
I-
Well, you
I
can,
do it
you can take the cube root of a negative.
visualize it.
Big.
So there wouldn't be imaginary, like
This is what you don't use.
3
Oh,
and a 3D,
well,
like if we were doing an XYZ plane,
I wouldn't use that teaching foil.
you could have a negative under your root.
Yeah, okay,
Under,
good. Don't even learn it.
so I don't think you have a
Verse
an imaginary component too,
Like foil, like top foil.
like through a 3-dimensional plane.
Yeah, but it won't work for binomials.
That would be hard. I was
I'm
thinking
trying
a 3-dimensional plane is the.
No, you didn't do it wrong. But you
You
don't.
took all of Y
So like
value
your
is
X
0.
and Y, for these guys, yeah.
And
Right.
all Y value is 0. But then the X value has
It's called distributive.
no X in it.
Oh, yeah.
And the imaginary X. So ignore the Y value since they're all 0, like
Because it only works with binomials and
on
binomials.
paper,
Yeah,
and it's all 0. So like that's
so it's just gonna be like just one plane with no.
Because it only works with binomial.
Actually.
separate the X value into
Yeah.
just the X and the imaginary.
So,
What I draw.
yeah, so Z.
That's
Yeah.
what I interpret the.
Oh, so that's me.
They're good.
But I can't.
That's right. So
So C squared times Z is,
It doesn't have to, I was looking for something like this.
you will prove it if you fill this out.
So are we saying, we're gonna graph, we're gonna
Times is,
Right.
Right.
And then that'll
Right.
be,
graph as if we did
They're showing us this.
maybe one.
I'm multiplying it.
you're distributing.
Another way
Yeah.
to write
But would be over to
C.
right?
Right.
No, you're not gonna break that up.
so the chord here would be
You
Oh, I
can't,
see
it
what
won't
you
be
mean.
integer.
I get it.
over to
Coefficients.
I can't, well.
chord here too.
it's like 8, 6, 7.
It's only, yes, we only have one. So one of these, okay.
What are the solutions?
It's not quite up here.
No idea, like you graph it, it only crosses at one.
This,
It's roughly here, right?
That's what there's.
the reason that doing it written like that is usually.
Or maybe I should just make these instead. Probably be
Right?
get a better visualization, I think, right?
I,
Or did
I'm
you go
just
by a
blowing.
quarter?
I'm
You went
grabbing
in a quarter.
These factors.
blowing it up. I don't know
What makes this feel?
how precise.
Is it in your head?
Wait, what are we trying to, z squared?
Plus z should equal 1. Or
Z squared and Z should equal -1.
1, 0. So that's the only one that's gonna be right.
Oh, yeah, so
For that one.
yes.
And then we have -1/2.
I don't get it either. So z squared,
So this, so the, so if
Not quite halfway or a little over halfway.
A little bit.
A little bit below halfway, right? Because it should be like 0.8.
so these two,
Yeah,
actually one doesn't,
one works.
one works.
But if you use this,
So-
if you use it in this form,
What about
is it easier to
the-
look at?
5.
Yeah,
Three,
it's,
the third,
but you're not,
third root of one?
Tell my kids to help me.
Yeah.
which is one.
Yeah, just below.
It's one.
And that means we'd have one on the other
So it's
side.
the same value. So
Or we
like,
have
like say 1/2 and then
so
also,
down here. It would just almost look like a reflection.
it's gotta be a different value.
What's the number when you square it? What's the number? Maybe just.
We do.
trying to figure it out.
I'm trying.
Like, my brain.
I think there's
Can you
Even if you
imagine
worked on
it?
this problem before, please try it again here.
Okay.
Complex, ooh, complex number.
Yes, but do you just notice that Bowen wrote a calculator may be helpful here. So take that seriously.
I graphed it.
You graphed the 3 solutions?
No, I graphed f of x equals x cubed minus 1.
So we would grab.
But that didn't help.
You graphed that on a regular real plane.
Yeah.
Yeah. So what you want to find, so you found a real solution when you did that, right?
Yes, yes.
But there are 2 other complex solutions.
Can I graph? I've never graphed anything on the complex.
Well, it doesn't really work that way, right? I mean, the only way, right? Like you have a plane that has your x values, and then you would have another plane that would have your y values, right? It's not like you have a line and a line.
yeah.
So you would really need 4 dimensions or a different kind of representation.
Oh, and then you put the X, okay.
Yeah.
Yeah, it's been a while since.
But you can graph the solutions.
So then we can say.
Yes, but we gotta
Right.
find
Yeah.
first.
You got to find them first. But just like you can graph the solutions of that
We'll have.
real function that you just graphed, you could graph that on a line, right? You can graph the solutions to this on the complex plane,
It was one.
but you got to find them. Use a calculator.
Well, one is probably for 3/2. It's -3. Right.
Yeah.
That's the exact.
So I'm just gonna guess, like 1 minus I. Does that work?
I don't understand.
Which one?
Yeah. Excellent.
Yeah, we're really.
But is that for A
Oh, and I didn't plot
or Z
the
cubed
one.
minus 1 equals that?
So there's our. We.
I'm just gonna guess it.
Isn't there everything stats? I don't know if at all,
Does it? Zooms that? Oh,
because at one point it should be a little bit further, but that's would be,
mhm.
yeah, if you did zoom. And then I think stat is 9 or 0.
9.
It should look kind of bad.
Looks like a parabola this
Yeah, if you turn it,
Yeah.
it's parabola.
Yeah. Or a triangle.
Or try, if you connect it now, it can be a triangle.
So is it 36? These would do you make it a 36?
Why does mine look way too equilateral? What did I do wrong?
Well, maybe the screen is like, you know how it's wider. It's like a. So it's
Well,
just-
because it should only be, that one should be double the distance away from the heart. Like, on the left, going with your X value double the distance.
Mhm.
Maybe it's just the
So-
screen messing with.
So this is just like, so you mean the whole thing would be root 3? Because it's root 3.
So from here down to here.
Is it related to what we did?
Thank
It is
you.
a distance formula.
Yes,
And
what type
triangle
of,
is-
yes.
So if we did.
Curious.
So what is 1/2 squared plus root 3 over 2 squared, right? And then square root of that. Oh, it's 1. This distance should be 1.
Oh. But this,
Oh no,
The
not the
dis-
distance. What did you do?
the distance.
I can't do the distance. That's my issue. Oh, I'm just messing.
Chicago, are you still guessing?
Yep.
Because if I were you and I were going to make some good guesses and I knew Bowen as you do 10, I might make guesses based on other numbers that you see on the page.
Hmm. Okay. Would factoring the z squared plus z plus 1 help?
Well, you could, I mean, you have tools that you could use to solve that. Maybe not factoring, but
In this one, it doesn't matter for
Mhm.
that's a quadratic, right?
Yeah,
2 root 3.
but what does it equal?
Well, yeah.
0?
Root 3 over 2.
I mean, it doesn't, if you want to find solutions to
3.
that equals to 0, then you set that equal to 0.
Oh, because of the c square.
You called that.
I
So you
forgot.
said that this is root 3.
z squared plus z.
Oh, and the diagonal is also,
This I didn't do the diagonal. I just did this one.
oh. Oh, I assumed that, but you said it was, so I.
Oh
just
yeah,
checked.
sorry, yeah.
So it is.
That's what I was just
Just
checking. Yeah.
verify, but I did the diagonal.
So that means,
I think I did the diagonal. You
So
can
let's do the
double check.
diagonal.
right?
So we have 1
That- negative one.
0,
And then
and we have negative 1/2. And the diagonal should be the same length because they're.
Yeah, I just did.
Let's see.
Like something.
So we get
what's this?
negative 1 plus root 3 over 2 squared. We take the square root of it. I think I'm getting what you're getting. 1 over 4. I get square root 3 for the diagonals too. So I shouldn't have let the screen deceive me, right? That's what I'm saying.
Yeah.
So we have an equilateral triangle.
They're square root of 3 apart from each other like that.
So the 3 points are, so you graph the solution of Q plus 1. We discovered that the 3 points are all square root of 3 maybe units from each other. We make an equilateral triangle.
Oh, and that's
Therefore. I wish there was a quick button for the therefore. or something.
Because it's a third,
Yeah,
it
EQ.
end up being something still in square root.
Oh no, at IL, EQ, IL,
I just did the second, the quadratic.
AR. Yeah. equilateral, ERAL. So no I, yeah, no I being there. There you go. I think that's how you spell it.
Yeah.
Form an equilateral triangle. So this would be, so this is still C.
I'm gonna skip to
These without the decimal conversion. That's complex.
C.
Oh, we have to.
So for two, so I wonder what the, did we start doing something like this last time?
Yeah. I think so. But now I.
Are we just looking, so we're just looking at the top
The
one here? Right.
Yeah,
Yeah, we did something like this last time where, weren't we doing?
yeah.
But I feel like now, would we be working in mod 3 now instead of?
Chicago, how's it going on that? On finding the factors.
We are,
Take a picture.
I completed the square.
Uh-huh.
Trying to reason my way through it.
Okay. Great. No, that's great. Take your time.
What are you guys doing, Jen? Jen's skipping to number 2.
I skipped to 2.
Oh,
It's fine.
I couldn't handle it.
No, don't skip to 2. Use a calculator or take some guesses. You can take some guesses based on what's on the page.
How about this? Let's guess the 2 and the 3. Like do something with the 2 and the 3 as a solution. Like do 2 minus I. Maybe that's a solution. So guess that.
What if
Where is it? Just this?
one of the solutions is the norm of 0 plus
0 plus I, which is this I.
the norm of 0 plus 5.
Oh, during the trip or during the trip?
Oh, maybe before.
Minus.
That's great. Maybe I'll
So I.
burn 10.
The norm of I.
So which is negative I squared.
So we're doing, I feel like we
So that's, so like,
I like the
keep
way
it
you
a
wrote it.
fraction.
Which is just.
So we're taking,
1, which is our solution. But it's
I just want to see where. So we're
Yeah,
taking
but it's the same value.
plus
But doesn't it have to be the same
So
value?
we're taking, I'm gonna write even as negative a half plus
Because 7,
3 over 2,
7 and 1.
just because I like
It's not
that
the same
better.
as
Yeah.
1. 7.
Or root 3 over 2. And we're multiplying that by itself. Negative 1 half. It's gonna be a crazy calculation.
Four, I plus 3 over 3.
Right.
Our own solution right now is number 1.
Minus 2, 3, 1 half minus 3 over 5.
I got negative 1 half minus I root 3 over 2.
Okay. I got, oh, yes. Okay, no, okay, check my work. Okay, I did it wrong.
Just because I just rewrote some
It
stuff
is
around.
negative because 1/4 minus 3/4 should be negative.
So the only thing that changed was the sign of
The second number.
the second number. which we've already have graphed
Okay,
on,
now we have to do it 3 times.
and then we do it again.
I can't, one more time.
So I think
It's
then
gonna,
it's just gonna keep going.
it will take.
So if you
around-
start in quadrant 2, square, and go to quadrant 3.
So maybe the next
So
one is
now I'm gonna
quadrant
hypothesize we go into quadrant 4. That's gonna be my guess.
Let's write the hypothesis and
Yeah,
do it.
before we do it. So we said, so for 2A. For 2A, our point, or something, I'm trying to see. Our point reflected over the x-axis into quadrant 3 or something like that. Does that make sense?
Oh my gosh. It works.
You got them?
And then we hypothesize.
Wait, Ton, did you get it? I can't see your face.
that
Well,
we
negative 1 plus or minus the square root of 3I over 2.
in quadrant 4.
Yes.
Hypothesis. I think, yeah, I think you're good.
Let's understand.
Yeah.
Check that. All right.
How did you get to that?
I put a couple of emails we have between us, these are like, that's for professional
So
class.
just look
That's
at
what
that.
it says for number.
You use quadratic formula too, right? I didn't, because I did
It's not
quadratic
really-
formula if you're used to it. It's probably-
But we're multiplying by,
It's right there.
That's why, I remember when she was like, look, okay.
Don't put it over 2.
That's what I was thinking. I was like, geez, and I
No.
plus,
did it on your own.
So like,
Wait. can I
so you're
see?
solving this, right? Z squared plus
Right,
Z plus 1 equals 0,
right,
right?
right.
And then I completed the square, but you can just use quadratic formula to do that. And if you use a quadratic formula, you're going to get that. If you complete the square, you're also going to get that. And then I plugged it in here, so I just like cubed that just to make sure that it was going to work. Like I squared, I mean, I multiply these two.
that's nice.
Also, is it going back here?
Cancel.
It will come back to like,
So I have, let's see,
is it the imaginary quadratic?
imaginary part cancels there, and then we get square times 3.
Yeah, so how do we plot that?
So we get 1/4 minus negative terms and plus.
You guys have graph paper?
Yeah, got 1. Yeah.
Got graphic.
Oh, so our hypothesis was wrong. Or are we just going around? We're just going around the points of the triangle.
I wonder, but last time I thought it was.
Wait, Chicago, for real.
I don't.
Are you working on graphing it? Ton, I can't see your face.
Yeah, we're working on graphing it.
Okay, good. Let me know how it goes.
Because that's. So that depends on the different.
Is this last time we did 4?
Last time is 6. This today.
Oh, take
today's
7.
Good.
That's what I was confused about.
Why do I use a graph paper?
You have like.
Well, there isn't. So it's negative. So you break that up. So you break it up into negative 1/2.
It was
Oh,
a big
here's-
before.
The square root of 3
Oh, there
over
you go. Then
2
there's the 2
I.
other. Yeah,
Yes.
you're right.
Oh, this, is that the triangle right
Yeah.
here?
So we were
We'll
doing
do the solution.
question 8.
And then 1 and 0.
Question 8.
How can you?
We were taking 3
Graph it from. That's how you do the.
different points. And the triangle
No,
got rotated.
no, this one. I think it's this one. This one is like that.
That was Z to the 4th.
You know how you.
The
You
seven.
know how to graph
7, we're using it based on Z to the 4th.
it here.
Oh, and that's where you have the.
That's where First, we kept walking around the circle. So see if the curve is coming around. Trying. Yes. So that would mean that z to the fourth, we should get back to the first point. That's what we're
Oh, like W.
saying. Yeah.
Let's
So let's first say our hypothesis was wrong.
Right, one, so it's a little less than one
Yeah.
on the vertical, imaginary.
Maybe incorrect. That sounds nicer.
incorrect. For 2A.
For when we calculated 2B or something like that. Like 2A, I don't think we made a hypothesis for 2A, what was gonna happen. So after completing after completing 2B, we realized our hypothesis was wrong or something like that, or incorrect. That's incorrect.
Negative 1/2.
W.
We can say W cubed equals 1. I guess now we hypothesize W to the fourth
It looks
No,
like
not
an airplane.
to W, or it's like W to the fourth should equal W. So now we're getting into if we're gonna use mods, like something like that.
I don't understand why we did it though.
And then,
So how do we say that? W.
so W to the power, to the n power is both, is
W to the n power is going to equal W. Yeah, I'm trying to remember 1, 2, or 3. How do you say that? We're using mod 3. Like, I just don't know how to say it. W.
on 3 points.
Yeah, I guess
It's related.
it's related to mod 3. I like it. I don't know how to say it. W to the n. I don't know how to say this. Would it be n mod 3? Yeah. W to the n equals W to the n mod 3. Does that make sense?
Yeah.
I think. Yeah. I think that's what we're saying.
Oh my god. Oh, those biscuits are really good.
Your Triscuits are
They're really good. I was thinking that too. They're like really good.
See, if we take 1 and multiply by negative 1/2, well, duh, that's
I'm good. Now that when you say it out, it's like we actually have a hypothesis. It's saying it out.
So it is negative 1/2
um,
plus I root 3 over 2.
And yeah,
And now it just repeats.
yeah.
So for D, W to the 5th is going to equal
if you make this
W squared because
I was squaring this way.
5
Well, I'll keep it. No, I need to square that.
is 5.
I'll wait until you're finished.
Why don't you square it too? Let's see if we get the same thing.
Yeah.
Yeah. And then
And then E
Good
W
thought.
to the 6th will equal W cubed because or I probably should say because 5 mod 3 equals 2. There we go. I feel like I'm just trying to put it in the right order, maybe. Is it sad I'm like I understand mods more now than I did when I took like all of my college classes. We did mods for like a month.
Sometimes it's just like.
I guess it's just
you
the
know,
time and place.
Yeah, and you know, like learn it and
One of those things.
then come back to the second time.
W6 equals WQ, which equals W. No, W the fourth is W.
What'd you get?
I root
Yes,
3.
technically it's 0, right? Or 6 mod 3 equals 0.
0,
One for us.
2,
That's good.
It's 3 mod 3 equals 0, right?
3 mod 3 is 0. Yeah, there's no remainder.
Yeah. Time for F. W to the 299 should equal
What do you get for three?
where? Because it's less than a multiple of 3. That means I have a remainder of 2.
What do you say you multiply?
299 mod should be 2.
Remainder of 2.
So I would break this up because this is really minus 1/2 plus I root 3 over 2 times minus 1/2. Did I miss a sign? No, okay. Minus 1/2 plus, again, the same thing, right? So you actually have
this
4
is the same
things.
thing?
You're gonna have 4 products. Because you have to,
Then this is this?
So W third gives 1. Anytime it's
with an
just
I
I mean,
there.
can I just break that?
No, it would be
I just decided.
0, which is W.
like, or sorry, like, sorry, the
Yeah,
like
the
the
answer.
answer. So like the
Yeah.
answer to E would be,
Yes.
the
yes,
answer to D would be whatever we did W squared to A.
Yes.
Negative 1/2 minus I root 3 over 2.
Yeah.
That's what I'm just trying to like
Okay, yes. yes,
say, like,
Yes.
so for H, W to the 3 over
Hmm.
W to the initial point.
Is this would end up being a half, right?
2 cycles.
Mhm.
I don't know how to prove you wrong.
No, stuff like 3, I think we did last.
Equals to that. We did. R equals to that. We have to plot all of them.
1 minus
Oh, I
I.
didn't think because the triangle.
Yeah, you did the triangle. I think I had all the root 3s on.
Where'd you get it in? I thought this was-
But that's why I become a wizard,
No, you
got
got,
it not over
I
2.
guess.
Yeah.
Yeah, we already did that.
what'd you get? Maybe I'm wrong.
Whatever.
I got this. This is what I have right here.
So like, do it with some numbers that we can
Alright.
unimagine. Maybe.
Well, it's just
Wow.
visible.
So what would you do? So using your process, you would get 4.
Right? Because 2 times 2 is 4.
Yep, and then you get 16 plus 32 plus 32, which is 64, plus another 64. Right? Is that using your method?
Mhm.
But we really know it's 36, right? We agree on that? So does that equal 36? 128. 128 plus 16 is 144
So you're going by.
over,
Let's go by a half, so like 6.
Times 6 equals 36.
because that's 12 divided by 2, which is 6. 12 divided by 2 equals 6. And 3, 36. It does. Something went wrong in there.
1, 2, 3.
So you got
Yeah, I did. I should have got a couple spaces below just to be safe, but
What I did with
Then you got another minus I, so that's minus 2I root 3.
Yeah, they're gonna do that. I have some bone fins and I ordered new bathing
I
suits.
squared
Post office, so I have to get to the post office before Saturday.
minus,
Go on Saturday.
so that's your minus 2.
I should have, I don't know why I got it there. I should have just delivered it home because I don't ever
We have-
office during the week.
So this is 2.
Minus 2I square root 3.
Point here.
I don't know. What'd you got?
2 plus 0. Yes.
Chicago, do you guys want to stop and talk to Nantucket too? They're here. Okay. But can you turn your camera a little bit so that we can see you?
Yeah, I'm sorry. I was talking to Jen.
No, I don't mean turn. For some reason, Ton, I don't know. Nantucket, can you guys see Ton?
Oh, I think it's the lighting.
Oh, yeah, that's really good.
Yeah.
Hi. Okay. All right. So Nantucket, do you mind pausing for a minute?
Sure.
All right. What are you guys working on? Chicago.
Number 2.
A.
What'd you guys get? We haven't compared answers. We didn't get the same answers. But maybe, did you get the same answers with Jen?
So, I mean, but you do recognize W, right? From
It was not like that.
It wasn't like that.
Ton.
What?
You do recognize W from problem 1, right?
Yes. Yes.
So, are you working on plotting them, or are you working on looking at have you plotted W yet?
We have.
Do you want to just hold up your plot to the camera?
We did it for 1.
Oh yeah, it's a little bit maybe hard to see. Okay, so you did 1,
Yeah.
and now you're working on squaring W.
Yeah.
How's it going?
Not great.
Well, we just did you agree with Jen?
No.
No.
None of us are getting the right answer, or they're getting the same answer.
Okay, that's okay. How are you guys doing it?
Making it into, I guess you can call it binomials, and then, distributive property.
So there's just some careless errors somewhere in the mix.
Maybe.
How about you guys? How did you guys do that, Nantucket?
That's exactly what we did. We separated into 2 binomials and then FOILed.
Yeah,
Okay.
I think I see my mistake.
I don't want to give anything away. So
Yeah. Okay.
answer yet.
All right. So anyway, you guys, Chicago, you're on the right track. Keep going. You did it exactly the way I would do it, and just the way Nantucket did it. So keep going.
But Jen actually did it another way. She actually just multiplied the 2's in the denominator and then multiplied the numerators as binomials. And that seems to kind of work too.
Yeah.
So she
Yeah,
split
thank you.
the denominator
It will. Yeah.
and then multiplied the
I think it works.
I'll end up bringing 4.
And then I factored out the 2 here.
that worked.
That's fine.
I mean, it should work, right?
I don't know.
Thank you.
So you just multiply it. So
I think it works.
So that's
At least for W square.
Oh, I see.
W to the
And then that's exactly what we already graphed
do everything.
for one of the solutions of Z. But why would that work then? Now I don't understand that. How would that work for Z cubed if it works for N squared? Because it's plus or minus.
Yeah.
I don't think keep going.
Yes.
W negative, and then like. I wonder if it would be. That would be like the center of rotation or something. Oh no! Well, we're gonna multiply and C. We're gonna multiply by W. It's like colored pencils really different. I have a bucket of them somewhere. Where did my kids?
I'm not multiplying my denominators.
Yeah, me neither.
Half W. Does it look like?
So W is like. Because I just went up by
That's my
one.
one.
I just went
Yeah,
up by one.
I followed you, so yes, I think mine, W so should be a little bit lower. Yeah,
Right, like just below, like,
just below one.
yeah, because it would be above the halfway point, because it's not 0.7, it's above 0.75.
W right here, okay.
Okay. So squared is
So we did that.
For 3,
B minus.
we'll multiply all by negative I.
I would be 4I.
That's what I got. W squared.
So A. We'll do it negative I.
Minus.
No, it's definitely gonna be a mod because I'm just.
I didn't need it, okay, so it's.
Is that what you got for W squared? So W.
I just figured out what these taste like.
That's not finished.
Monster Munch, pickled onion flavor.
I don't know what that is.
Pickled onion tomato flavor. Pickled onion.
Wait, so what'd you get for W?
I squared, or minus 4I squared, and that's plus 4.
Future Monster Munch. No, so this is gonna be. I think they're all gonna be. The signs are just gonna change.
The signs of what? The first term and the second term? Is it always gonna be negative 1/2?
My hypothesis.
So did you actually do W cubed?
Because now I'm gonna multiply by the same thing but different signs, right?
You just wrote it differently?
So. A prime.
I think everything's just gonna be rotated.
On 4.
So now, what we just did is what we did last time, I think. Except we were multiplying by positive I first last time, this one we multiplied by negative I.
Does it make it?
So it's we're rotating clockwise.
Clockwise is that?
Oh no, because my signs are different.
Yeah, because all we did was change, we flipped X and Y, and then negated Y. We flipped and negate this one. That's one.
Yeah, it looks clockwise.
Yeah.
The cubed I got.
Try to see, because I go like that, and then if we go like this, then we make that one. That's it, like visualizing is weird. So this one was a like 90 clockwise rotation.
Oh no, because I forgot to multiply.
That's
Hold
supposed
on,
to
hold
be
on. I didn't.
So you are suggesting we should,
Because exactly what one of the solutions
That's
was.
what we're just-
Yeah.
yeah, one out there, we don't know what's it for yet.
The W's are gonna. So we're taking the original AR and V and multiplying by W.
Was the
over
for part B.
We see,
So,
still haven't finished.
all right, sorry.
You go.
I'll
go
start
ahead.
with
No,
this
no, no,
one
you
and
go.
two.
Yeah, you go ahead.
So
I'm just like double checking, make sure we can hear it.
so we
So that's gonna be a difference of squares, right?
Something wrong.
Well,
Nothing, I just like everything that I'm doing wrong is just like stupid.
so 3 squared,
It's stupid.
3 cubed is 1.
3 cubed is 1. And then 1 times the original, right, is going to be the
So
same.
W fourth, W to the fourth is what?
It's going to be 1 times the original.
Is negative
Negative
1
1 plus I squared root of 3.
over 2.
Mhm.
What about the fifth,
And then that's going to be the same as W squared, right?
which is gonna be the same as W squared. W squared.
So it will be like a mod 3.
So mod,
And there were 3 solutions. for
let's
Z.
make a table. So W squared is
W squared was negative I. W was negative 1 plus. Here, your box of expo markers is right now. Negative 1 plus I square root of 3 over 2 was negative 1 minus I square root of 3 over 2.
Now this is like
1. And then it was the same as W. And then W to the 5th would be the same as W squared. And then W6 would be.
I see what they're saying. Use decimals. Because they all have the complex numbers that are right. So it's like it's getting a little
Oh, so like just,
nothing too crazy, but the craziest one is just T double count because we're multiplying it all by W. So like yeah. So like so far as like I'm just glad that the 4 was in there twice because I just has all I did was just copy that back then again. You know, simplifying.
definitely,
Into decimals. Once I get it all fully simplified.
I'm gonna check up my calculator for you. Yes.
Two.
I guess my calculator did 4.
So the one you should be here. So I haven't fully printed.
I didn't.
Mod
We can't even,
So which one did you just do?
I just did A.
Oh, you put A into that one? Oh,
Well, I asked the calculator.
what it is.
Like, I think I get that step, so. Yeah, you got -2, so 2 times radical 3. Yeah, It is.
Okay. So that's what I was just gonna write down at this point. So 2 and 3. So I use like 3.46. So I have -2 plus 3.4.
Got it now.
Nice.
So then -3 was like 1.6.
Thank you, Jen.
173.
I get it. Yes, there's not three.
So-
Wait, wow.
-2.
That's all it matters.
3. Really? No. It's off my grid.
So how big is it? Wow,
-5. Did I do that right then? Well, no, because 2√3 is 3.46. Did I multiply this right? That's what I guess I should just say.
And the calculator.
So it's -1/2 plus 3/2. Oh no, they're not multiply all that.
Oh, and you guys, we've got to take a break. Oh my gosh. You haven't, none of you has really looked up, but let's take a break.
Okay.
5:32. Yeah, let's take a break. We'll get back at 5:47 Central. Okay?
Sounds good.
Mhm.
Right. I'm trying to remember, like, in like all of my geometry classes today, I did not get through what I wanted to get through. Like, no one wanted to work today. Tomorrow's gonna be even worse.
Yeah.
Like my CP class I don't see tomorrow. They have homework for me over break because they couldn't finish their work today.
Yeah, same.
And I'm like, I really don't have sympathy because like they chose not to stay on task.
I finally bought a new, if you need to use it, I have an origami documentary.
Mhm.
So,
Maybe next year.
okay.
They're doing work. I want to get through the lesson I started today. I don't want it to linger after break.
Mhm.
So I just need to figure out what I'm doing after that.
I'm definitely showing that to my CP algebra too. For my geometry, I think I started something too, so.
Yeah. I mean, for the class I just picked up, that geo class, I'm giving them this like survey thing tomorrow because I don't really know any of them. So I'll play it as if it's like day one.
That's
So I'll do that with them. And then my co-top class, I gotta get through my rhombus and trapezoid lesson. I'm not gonna start the next one because it just doesn't make sense.
Yeah.
AQR, I just have to finish what we started today and yesterday. Like AQR, I planned to be big enough where I knew we weren't gonna finish it today. Just as we're talking about sine waves still.
Yeah.
There's so many real world like things that follow the cycle.
But the trick, like graphing trick, was so difficult when I tried to do it with algebra too. That it was like very frustrating. But I hope I'll do it again. Probably if I have time in the end of the year, I'll try that one more time. Yeah.
Especially the ones that go into pre-calc. They're the ones that are gonna need to know it more. And then,
Yeah, I have a couple of freshmen who I don't think should go because like they just so like there's stuff that is so obvious that they don't get now and then.
hey kids, so we're doing trapezoid problems today, like honors geometry, and it was solving for the height, and they were like so confused. Like, you're just getting h by itself. Oh no, you have to add two numbers in a parentheses first. Like,
Yeah. The other day, Prashaka asked me, like, is x squared plus x squared equals to x4? It's like, Prashaka, if you don't remember little things like that, a pre-cap is going to be hard for you.
Barone's not gonna have pre-calc. Jed's got all the pre-calc next year.
Yeah.
Some of them, I can see some of them dropping out.
First, yeah. The first
There's no way she's gonna get through JED. Like a class with JED, she's not gonna get through it.
Yeah, but sometime when they get in there, they're too lazy to switch to whoever.
And she's gonna be the one that's gonna go through and get a 70 in pre-calc.
Yeah.
I feel like some of my days are off. I think the seniors has to be, today should have been day 50. Because it should be exactly a couple of weeks after mid-quarter 4.
No, I have a
I've
kid.
had all these countdowns.
I have a kid countdown for me because he's a senior, so it's only the countdown for senior.
I just put it all in there because it all is important for kids I have.
Yeah, for the MCAS and the bio and because they all need to get the act together.
I told all of my sophomores, like all my geo classes yesterday and today, that guys, when you get your comments, I was honest. I said for every single sophomore, I put MCAS tutoring recommended. And again, even if you have an A in my class, you can always do extra MCAS review. Like Ashlyn should be fine. I don't see anything for her. Cammie is fine. I just wish her attitude would change a little bit.
Yeah. I know.
And I have some sophomores that think
Some
they
of
should.
those sophomore girls sometimes can be really like nasty on their.
And there's some, I feel like as a whole, I think the sophomore girls who took honors geo last year, I think are much stronger than the boys. From who I had. Like,
You didn't have Brian.
I never,
Brian is awesome.
like the boys in my class last year, some of them were really good, but some of them were tough. Do you have Orion?
Bowden, right? Bowden is good.
I have Bowden. Bowden would never want to do work though. Like he would get, so like what dragged his average down with me was he didn't do homework and he would never show his work. So that kind of, but he knew like
He's quiet. He's like.
he is. And Isaac's out, like Isaac knows the stuff. He just doesn't do it.
Same.
And I think there's a Corbett that's a freshman. That's their brother too.
Really?
I think
You
he's,
have him?
no, Janelle has him because he's in Algebra 1, but he is signed up for Geo and Algebra 2 next year. But I think from the sounds of it, he can do it.
Okay.
So we'll see. I didn't do, so when we had the freshman class selection thing in the auditorium, I did not say, like, if you're in Algebra 1 now, you can double up. Like, that's not the time and place for that.
Yeah, that's a good.
So then whoever has the freshman one next year, like, don't tell them that.
Make sure that they don't, because sometimes you get, but I think there's a couple parents who want their kids to probably kind of know and gonna do something like that.
Yeah.
But they don't announce it, so that's good. I'm getting it ready.
I think I can do the rest of my teach point from home. I think it's all, everything else I need, I think I can just get on the computer. Or I can it's either in my Google Drive or I can.
Do you notice that probably you can't see, but Jen Sardellis was in the bathroom, keep waiting for somebody.
Yeah, well, during the class before advisory today, I had just gotten my kids doing something. I sat down to take attendance and she walks into my room. She's like, "Can you come here for a second?" Sure. She's like, "Yeah, there's been a kid in the bathroom for a really long time. Can you just go in and see, first, does it smell? And if there is somebody in there." So I went in, nothing really smelled bad, but there was a kid in there. And I'm not busting down a door if a kid's in a stall.
Yeah.
But she's like, "Yeah, he's been in there a really long time." I'm like, if he comes out, I'm not gonna pull him out.
He's been waiting there for She's been waiting outside.
I wonder if the kid ever came out.
I wonder who's this kid.
I don't know. I'll probably get the kid next year. Do you have a Ryan Daly this year?
Almost.
Oh.
I had him 2 days, and then they said, I don't know if he's sick of me or sick of Nancy, but he switched out of both of our classes and get the Paul.
Does Paul have CP?
No, he has one honor.
Oh, Paul does have an honors?
Yeah.
I don't know how, I have to ask Paul how he's doing, because he was terrible. Like, he was just immature, and he didn't know the material.
Yeah, he does have like an attitude, like just the second day. It's like,
He would never.
I'm glad no showing work. I'm glad I'm getting out of
Well, the thing is, like, he wouldn't show work, but he was doing it wrong. Like, he was never doing work right for me.
But yeah, it was in my small class too, but he switched out like second day. So it was good for me hearing from what you said that, so he's
Last year, he was a tough one. Trying to think of it. Do you have Sophie
Yeah,
Girardi?
talks a lot.
She does talk a lot.
But
She's a good, I liked her a lot. I had her, she doubled up last year. She was with me for Algebra 1 and Geometry.
yeah.
So I hope she's doing well
She's
for
doing
you
well.
this year.
She's doing well. Just talks a lot and like doing appropriate things at an appropriate time, but she knows her stuff. So,
Yeah.
like, you have to remind her. It's like, we're starting class now.
Yeah.
Like, she's like full of energy.
Yeah.
And it's like everything. It's good to celebrate, but she celebrate like super loud. She's like shout on top of the lung to say something or stomp if she get mad. It's like
In Algebra 1, like, she was so misplaced for Algebra 1. Like, because she was like just so far ahead of everyone else in my Algebra 1 class last year that it's like, there's her, and then there's one other girl. I don't think you have her for Algebra 2. Addison. So I think she had Watts. Addison,
She,
Pineda, Kendra.
I don't know, but is she Hispanic? And
She's Hispanic.
But she's in CP.
She's in CP Algebra 2.
Yeah.
So
but
maybe she's in that room.
She's in that room.
She's in that room. She's a really
She's
good kid.
Yeah.
She's like math-wise, she's really good,
Yeah,
and she's just a good kid.
Yes, my fine. Oh well, I don't know. You didn't see her in 7th grade, so
Oh,
you have a new freshman.
I only
but
saw her. I saw her in 9th grade. Like from
From now, I see
Yeah.
her change.
like she's
a
changed.
lot.
Okay, so
Yeah.
that's
Yes. In 7th grade, she would be like laughing at every single thing, and then sometimes you speak in Spanish, and then she'd laugh at that, and then you didn't like. I guess I'm paranoid, but then she wasn't listening. She was just like giggling all the time, and I was like. But now she's like, very polite and
Yeah.
like. Say,
she's very focused on her work.
and
like,
then
now.
she able to catch stuff like that, like and gets very quick. I thought she would be in the honors section, but I guess
I think she's doubling up too. I have her in Geo. She's in my I had her in Algebra 1 last year, and she did ask me. She's like, I want to take both because I want to take AP Calc. It's like, you can do it.
Oh, she's a sophomore.
She's a sophomore.
Oh, okay.
So yeah, I had her freshman year, Algebra 1.
Mhm.
She's in my honors Geo section
This year.
this year,
That's good.
and she's also taking Algebra 2.
Okay, that's good. Yes, I think if you're doubling it, you can do one honor and one
CP.
Because I think I have another student that Lily Logan. Yeah.
I've heard the name, but I haven't remember.
Okay, she's
Sophomore,
doing,
though?
Sophomore, doing the same thing. Like, so it's good that you can expose to the high order thinking of the honor classes, but
Mhm.
not to overwhelm.
Yeah.
You still have the algebra 2 and that too.
Yeah.
Yeah, do free calc. But that's a good goal for Addison because, like, in that AP Calc class, it's not, by the time you get there, there's not a lot of minority left.
Yeah,
And
it'll
it
be
would
really
be
good to see.
Good too. And then Brian is good. That he's like Hispanic, but he's like his sister. Was it Marjorie that
Oh, yeah.
But then actually Brian is a little bit higher up than her, because I had her sister in algebra 1, so. I think there's a lot of really good minority with that spec, that, and hopefully I hope that they can make it to AP Calc.
I have a girl in Geo this year who's like, again, she's my CPGO language, but like she's EL services and stuff, but she's like come such a long way this year. And I've heard like her other classes she has too. She passed the bio MCAS on her first go,
Oh, wow.
which is really good. She's always like involved and engaged in class, which is really good. So I hope she can pass the math on her first go.
Yeah, I think if she does the bio, I think hopefully it's,
I'm hopeful.
yeah.
Fingers crossed. Especially when we start reviewing. It's
Remember
not sure
the-
how her
Run to the bathroom before.
they start.
Okay, are you guys ready
Yes.
to come back? Excellent. Okay, Nantucket, how's it going?
We're
Good.
good.
We are working on the number 3.
Excellent. Okay, great.
You grab.
I wish I was hoping I did something wrong so I could fix it, but I think only because this point's not gonna fit on my graph because of I need a couple more spaces after,
Oh, can I see the other point? Let me see if I can grab it in
I
mine.
think, because I had
So -2,
-2
and then
and plus 3.46
1, 2, 3.6.
and almost 3.5.
Almost 3.5. So
Yeah,
right
just
here, this
below.
is
It should be like just below 3.5. Like
just
because it's 3.46. So
Oh,
really
46,
like almost 3.5.
and this is point A.
That's it. Yeah, that would be a double prime.
Okay.
And then R double prime should be -1
1,
and then 1.73.
like this is R double prime.
R double prime.
Okay.
T double prime again, -5.46.
-1, 2, 3, 4, 5.
And then almost 5.5 at that point. And then 1.46.
1.
So like 1.5-ish.
And this is T.
That'd be T double prime. Okay,
Looks
there's that here. Would that still be a right triangle?
like this point kind of is like,
Did I calculate something wrong?
no, well, no, because
Well, we didn't multiply by the same. We still multiply by the same W. So maybe right triangle, but not necessarily
like it's similar,
like a similar triangle.
and then you want to check the distance between these two.
Because from here to here is 2.
Here's, I mean, looking at the pictures, not,
Because now we're decimal
yeah.
approximations too.
So let me see, what's your A, let's do the distant one. A prime is 2, -2 plus 3.46i, and then R prime -1 plus 8.73i. So, but even if we do the distant formula, it might be also an approximation.
We can get we could do the exact, because this one is just like three
Okay, it's
stuff,
not
so
that complex,
not too bad.
too bad.
So we just get
So,
-2 minus negative plus 2, 3 minus root 3.
One.
And square root, that's 2.
So it is,
It should be 2. So,
okay, so
yeah,
it's just drawing.
it just, yeah, so I'm sure it all
Okay,
probably
so-
still works out.
So it's the same, so same triangle, because, do you want to check the thing?
Would W just be this?
I could
Well,
not figure out where the,
No, look here, look here. If we rotate it this way. Oh,
maybe it's a.
maybe. Oh, I guess it could be, yeah.
in
Yeah, because our
this-
order is still the same.
we can find this, or we can find this is fine, we can find this angle using R.
I believe you guys can come back and do
And you're saying that,
Like a double,
so this is 1, this is √3. So this angle,
would be 6.
uh,
Because tan of root 3 is 60.
so this is.
No, yeah, tan 60 is root 3.
it. Working on now. No, I was gonna.
Wait, maybe I didn't
Okay.
change it to degree. So 10,
Do we?
yes. So that means it's a rotation of 90 plus, no. If you say this is 60, this would be 20, right? So it's rotation of
I
90,
guess you can pick it on that.
120.
So like,
Counterclockwise.
it's a multiple of 3.
It used to make sense if we did a 60 instead of a 90-degree rotation.
Like if it's a remainder.
When we had it, I guess,
Remainder of,
Because the other one is keep rotating like,
remainder.
instead of rotating 60.
around, yeah.
Wait, remainder of 1, it's W.
That's accurate. So what happens to complex numbers? So -1, we were just rotating around the origin.
Just the other way.
Yeah, it just negative, when you multiply by -1, that's when we
This would.
rotate 90 degrees
Uh-huh.
clockwise
Wouldn't 300 be
around the origin.
1?
W.
I'm trying to remember how you got me to
W.
rotation.
W to the first?
Yes.
So if we were to look at,
First W.
Wait, that's not right.
Because this is point on, this is point on. And if this is the center of rotation, then it's.
so then A is the same because A is
Multiple of 3.
the same up 2 over 1, up.
Because
One.
3 is going to be a 6 is gonna be a
So A was 2 3,
So it's like
and
this.
this is 3, so it is the same. Wait,
It's-
wait,
Yes. A,
this, A,
the height is 2.
2 3, yeah. And
Yeah.
the base is.
Sorry
2,
for A. Yeah, A was 2 root 3.
and the base is
And
2.
base is 2.
I forgot what it's called.
So all we did was just, we kept the
Three.
same ratio. It was 1 to root 3, 2 to 2 root 3.
So it's a.
So the angle should still be the same. So if we look at
Three means
T,
three.
that's the only.
You look from here to here, so you have to do like
Then
this part, this angle plus
this.
W2 is.
So it should roughly be the same.
Yeah.
So in this case, is it, so we're saying it's
2 is
it's a
negative
20-degree rotation is what we said for those
Yeah,
other two,
because-
right?
1
Because 90 would be straight up, and then we're rotating an extra 30.
Yeah. And if you do 120 times.
That would get you 360 degrees around. Yeah, that would mean,
Earlier,
so
that
that'd be
triangle.
the triangle Y. Yeah, that's why we're coming home after 3 rotations.
Yeah, yeah. That's like earlier. But
So you're thinking that maybe for W, it's 120-degree rotation,
on the origin and it's
which would make
counter-
counterclockwise because of where W was, I guess, right? So let's see if I say there. So for negative I, we get a 90 degrees clockwise rotation about the origin. It's totally small. But then for W, it's a 120-degree counterclockwise rotation around the origin. Which I think
by negative
I
Right?
clockwise around.
and W.
Oh my
No,
God.
just A or 2.
Getting nitpicky like I said.
Did I
Tell
spell
them.
everything correctly?
Yes, you're good.
Okay, okay.
Not that bad.
So what is A?
Is that just
A
like
is-
4-0?
Multiplying by W
One,
is
4-0.
So it's
a 120-degree counterclockwise.
Oh, just like, it's just
2,
finding 3
0.
points, right?
just 3 points.
That's not as bad. I don't know why I thought it was really bad in my head.
Wait,
That's not bad at all.
That's 2, 0. And this is 4,
Yeah.
4I.
Alright.
I was just trying to like, everyone.
I'll do yours because
Oh, but I don't have the, did I have the first?
well, I have some of the word. This is what the word. Right. I can pull it too because we only need.
We have one. And then we put a trace.
It shows it. Oh, should probably pull that.
And then the thought process, I guess, dotted lines.
There we go. Sorry, just so we don't get all the extra. I'm mad at myself. I should just show 1.5 squares.
You never.
You never know. That's
What? I don't want to do C.
Oh my God. Okay.
Why not? Seriously, why not?
Because it's not negative I. We'll see though. Oh, it's not that bad.
It won't be that bad. And it will be worth it for D.
0?
I think we're good.
Yeah.
Well, let's look back at this one.
I don't know. Negative 4i.
So
I guess if we think like
Okay.
3 points and to go completely around, since we're technically moving the same distance. We take the 360 to go totally around, divided by 3.
Yeah, so like kind of making these connection points.
So this would kind of be.
Wait.
These would all be 120-degree angles here.
Yes.
Yeah. Yeah, then that's kind of like that. Yeah. Okay, so even though the angle of this triangle is 60, but
the rotation is actually 120 to get as one.
1.25. Interesting. I don't think about that.
Zero, 4. 0, 4.
Plus 2 is the conjugate is minus 2.
Or negative
We're
4.
going to be indicated by a bar over the number.
What's the
Yeah, or negative. I have negative 4i plus 4, but it'd be 4 negative.
3 plus 2i, so the product or integer. 3 plus 2i is a
Zero.
the integer, so it's
I don't know. It's 0, negative 4. You're right. 0, negative 4.
if z is a plus bi, its conjugate is just a minus bi. Is that what you're saying? Before.
There's like a double bar in the next one.
So they want the conjugate of the conjugate.
So we just kind of go back to
So is the conjugate
just
itself is
go back.
that like the inverse essentially? So you just go back to a plus bi.
Because the definition of conjugate.
Negative 4, negative 4.
What are you looking at? -4,
Typically, the complex conjugate,
right? So that's
where
that.
both the sum and the product are integers. So, yeah,
It'd be 0, negative 2. 0,
the
negative
first
1.
one.
-4.
And then they dance it. So what's the conjugate?
Negative. Either way, aren't they both negative? Because you're multiplying it by negative.
2 you can say is
I
2
got negative 4i plus 4.
i.
You multiply by
So
negative
the
I.
2 conjugate.
I multiplied by negative I.
Negative I times 4 is negative 4i.
2
Wait, look here.
0i, which is
Just I plus 4 is negative 4i. Negative I
like the product would both be.
4i squared.
Integers. But it didn't say, did it say like what are they
So
equal?
it's negative 4.
No, it can't be.
Right?
If 3 and if 3 plus 2 is include other polynomial
Points, I think it's supposed to be like the
It's
regular
over
number
here.
plus the I goes second.
So
So it'd be 4.
So it'd be 4, negative 4.
Oh yeah, and then it kind of like shows.
it's that way, right?
Yeah.
Okay, and then
Finally, the norm of z
Is
is equal to z times z's conjugate.
and,
Got plenty.
So the norm
oh,
of
explain why.
z times z conjugate. The norm is an integer.
One thing.
And then when you add the 2, add the z and yeah, it's an integer.
So we're saying
You watch someone else.
that z
I don't know how to plot TWA, just TW.
a squared plus b squared. I know that's
W.
sum is just 2
I only did AW, but I will let you know in hot second.
sum.
And the norm is like
2 times 2 root
Yeah.
3 is
The norm
it makes sense.
norm is equal to b squared plus b squared, which we showed the product is z
Yeah, it's
Explain.
like, I thought that is the definition of like the norm is the conjugate or.
So all of these.
Well, that's all whack. What'd you get for AW? -2 minus 2i root 3?
And then how far do they want us to go in?
I don't know. Yeah. We'll see. I guess.
Am I multiplying by 8?
So one thing I don't have are erasers.
Oh, I have that at calculator. I found a good deal. I can give you some. Mom, in Walmart.
I just like the kid. I just tell the kids.
Oh, yeah.
You can be all of your friends. How does the location of
-2 plus.
-2.
Where is the location? It's gonna be well, they're gonna be equidistant.
-2 and 2i root 3, which is about 3.5.
From the x-axis.
Yeah, because it makes us we'll talk about.
There's one that's just above, one's below.
Which is about 3.46.
Oh, like that. Oh, I was thinking they're even same distance from the origin.
It's still screwed up.
Yeah, they should be the same distance.
And they're equidistant from each other.
2 plus 2.
I mean, equidistant from the, yeah, you already said.
-1.
They can act as a reflection of one another. At that point,
Huh. Maybe it is still
the x-axis being the line of synergy.
interesting.
They're saying that A plus
-5.5.
Did you get the same thing?
Okay, you're right. TW is really something.
I factored out the I. I think that helps.
What did you get for
No, sorry, I'll let you. No,
is that what you?
conjugate, yeah, they're equidistant from the x-axis. The x-axis is the line of reflection. I think so. Yeah.
doing something right?
I almost feel like remember how we were just talking at the start? Look at the first neat stuff question.
Oh, the 250. Do you want to jump to that one?
I do. For one of them, we need isometric graph paper. For 7, we need isometric. But 5 is doing a bunch of conjugate stuff.
Mhm. We can do 250 if Billy says, but it looks like I have my phone find that. What's that? Oh, it's number 9. You can jump to this up and check it out. 250. That's like 25 times 10.
We have to think about that.
And then it's 5 times.
Yay.
5 times 50.
It's 5 times 15, so that number. So 5 15 squared. So all those combinations.
Yeah, so we have. Ten is 3 plus, so 10 is 3 plus 9. 25 is 5.
It's also
Plus
3 plus 13.
50, we have
Amazing.
7 plus I and 5 plus 5.
Figure something out.
2.
Verifying that that was. I think
Recycled. So this one I'm only getting two uniques again. Like it'll be 16 total. Mix all these
Okay.
together.
I was going to, but then I realized I didn't.
249 is not a perfect square.
You factored out the I.
I factored out the I. I put that over there.
It's
I'm like,
after 169.
I'm doing all these like
You don't need to do anything with that.
Can I just leave it?
Yeah, I've already got every single.
Yeah.
I know you're doing it the way they did in the beginning,
yeah.
but I'm only getting
It's just that.
these two as the perfect squares.
Right.
Okay.
Of course, I factored out two. I shouldn't have done that.
So 20. So I'm gonna try this combo first. So it would be
So something like
3 plus.
I axis, imaginary axis.
some combinations of like these.
So I have.
This is algebra.
Where?
So put the eyes together.
I'm getting the same combo.
I went through all the, I did it the cheap way.
13.
I didn't use the pattern way, but I'm only getting those two. So it'll be 16 total because you have 8 when you mix these around, 8 when you mix these around.
Because not like earlier was a 5-5.
It was 5-5, so that's why we only had 12 before.
Oh, but you trial all of them.
I tried all.
Using numbers, so that means. Yeah, because this one has a lot of multiples.
Yeah.
But-
But the only, yeah. The one that like makes me think.
Why is it always so two?
There's gotta be something out there. There's gotta be, like even the 250, like I was gonna say, even with 250, when the norm was 250, we only had 2 unique sets of numbers or something like that.
These three.
I don't know how to say it. Norm 250.
First one is
Which one was the first one? This one? Yeah.
-2 plus 2i plus 3. How do I plot that? Can you remind me? It is -2 and then
Which one do you have?
Set combinations. I don't know how to say it.
oh, I'm doing the wrong thing now.
Yeah.
Which
No,
were,
Negative.
which I guess which were 5 and 15, 5 with 15
This first
2, 3.
Oh,
or something. Yeah, we can say 5 plus 15i, but then like all those combos and 9 and 13i.
The next point is -1.
Like with all combination, yeah, and all.
Root of 3.
I can't think how to say it. Like,
So it's actually that.
different combos within the parentheses or something. I don't think. I wish I knew how to say this eloquently. So for like 16, like we had 16 total points or something like that, or 16 total complex numbers or something like that.
So whatever that is, which is there, like 5 point something. And then put this at
2, 3.
Ton.
Yeah.
Would you mind updating the?
We are on number 3D.
Yep, I know.
How do you spell drive?
DERIV.
For, yeah.
G plus G.
Yeah.
-2 minus 2. Minus 2. I'm gonna do something.
Which one are you working on?
I just went back to number 5.
No, five.
So I just did the first one. The first one I'm gonna add.
Oh,
Like the first one, you add the complex numbers, then take the conjugate. And the second one, take the conjugate, then add.
Give the third.
2 square root 3. Yes. Okay, I think you got it.
Minus 2i.
Minus 2 square root 3. Oh, yes. Yes. And now we're figuring out how to plot it.
Mhm.
So add them.
So that like multiplying by W.
Plus 2. That is not add. 4 minus 2 is plus 2, not negative 2. Never mind. So
Plot it yet? You guys plot.
I think for the first,
the conjugate of the sums equals the of the conjugates. is that how that's
and then 3
conjugate of the sum?
here,
Wait.
I'm not gonna be able to say that eloquently again.
like the points for the variable for A. Times
AW.
W, AW.
Yep.
Yes. Big -1 square root 3.
That's AR.
Let's see, up the next one.
So
That's
The first
AR.
one
But that's
was-
fine,
The first one was,
right?
the one you did before it was 2.
There we go.
AR.
Yeah, that's AW, isn't it?
each conjugate, yeah.
RW is.
RW. Yeah.
Yes.
Oh shit. There
Now
goes
the
label.
products one works. So we're gonna multiply G times H and then take the conjugate. Sorry.
What was your question?
How are you plot TW?
So you can figure out where it is on the real number axis, right?
But if you want it. Would your eye say it? You can figure.
Oh, and then just.
Oh, but that's why my weights wrong.
Conjugate, I got 23 plus 14.
-2 plus 2 root 3.
to do each of them.
Negative 2 plus 2
It's in the-
Would be 1.
is your I and then on your imaginary axis.
Yeah, I get a 2 minus 2 root 3 would be the x.
I think we the same thing.
Interesting.
Oh, yeah. We didn't write it in that way, right? 3 is the 1.
That would be negative 2, 2, 3. Yes.
Right? Does the I point? the I
Wait, what's
come first?
opposites?
Wait, wouldn't RW be negative 1 root 3?
In C? Is this all in C? Yes.
Say that again?
RW is negative 1 root 3.
Negative 1 root 3I.
But
I
you don't,
get-
for the coordinates, you don't plot the I, right?
Right.
So it'd just be
Right. Yeah,
I don't know, yeah, I'm looking at a few pictures of that. It's got lots of different
negative 1 minus 2 root 3, comma.
Today's
Negative 2. Say that again?
For TW, the points, that would be
It's just playing.
negative 2 minus 2 root 3, y would be negative 2.
That's my running issue this year, the internet memory.
I don't know.
You see the new way for photo, for copy?
that's nice.
You delete that email,
I have
you
scanned it.
have to scan your ID.
The
I like that you can go anywhere. So if like someone already had a big print job at one, you can just go to another.
Yeah.
But now they're gonna be counting how many copies we each used. It's so frustrating because we have, like, we don't. And I'm not gonna make kids do math on their computer. Like, I want
Okay, you guys, should we come together in 2 minutes just to share
Mhm.
where we are? So work for 2 more minutes and then we'll just have a couple minutes wrap up.
Oh, we're going to do W's.
W stuff.
You have one piece.
Yeah, all this stuff is.
Same triangle. Because
There's 6.
Yes, I guess you're right.
That one's not too bad.
so like I did put that in terms to figure out that.
Minus 5.
I was confused about when you did like 3I squared. You get a negative.
This one's probably easier if we separate.
I mean,
Yeah.
do you worry about the imaginary thing at all? Because I don't think you do. No, I don't think you do. So you ignore the imaginary crap. Yeah. So I thought you maybe considered the I, but you don't because when you plot it, you don't.
Yeah, what we said before, it's just 2a. So like we multiply 2 times negative n, which is negative.
Right. So this is length of 2. This is length of 2.
Why multiply by?
Before, when we did our little proof before, the sum of the conjugates
Oh,
is just 2 times a.
oh, because of the p cancel. Yeah.
And the product is a squared plus b squared.
I don't know how to
Or
describe
is that the product?
what's happening there. Like,
The product should be negative
is that more than 90 degrees?
1
More than 90.
plus.
There's a lot of it.
There's so much.
Well, four is
Without even,
2
without
squared.
even thinking about the I. Just,
Without even thinking.
oh, but with the I.
20.
Oh, yeah, the I should, yeah, because it's a squared plus b squared no matter what, right?
Yeah, yeah. Because of, I think
Because it'll be negative I squared.
This is the complex.
yeah.
Am I doing this right? No, because you'd have the negative, you get a negative I squared, which would turn into just +1. So that's why you can just do A squared plus B. Ignore the I.
Okay, you guys, let's just come together for a couple minutes and talk about what we're doing. So you guys Chicago, have you guys finished 3?
Yeah.
Good. So what did you find?
That A and B are the same triangles, but B is rotated 90 degrees counterclockwise. No, clockwise. And then we think C is the same triangle too.
Uh-huh.
Know what the rotation is.
Technically, we're the same.
I checked that base, that shortest side is 2, just using like distance formula.
Mm-hmm.
But I didn't do the other 2 legs.
Mm-hmm. Mm-hmm. So what happens to a complex number when it's multiplied by negative I?
It's rotated 90 degrees counterclockwise.
Mm-hmm.
Or clockwise.
So the complex numbers, which switch negate them, and that's where that.
Which way is counterclockwise? Counterclockwise is
You
this way.
want to go clockwise.
When you're multiplying by negative I, which way are you going? Counterclockwise is this way. Clockwise is this way.
You should go to the right.
To the right.
Well, you
Like
go
the
from
following
quadrant
the-
4 to 1.
Yes.
2. Yeah.
Yes.
One.
Yes. Yes.
Sorry, 1 to 4, 4 to 3. Yeah.
And then what about, so Ton,
Yep.
you guys have a theory that you are also rotating when you multiply by W, right?
Mm-hmm.
And then do you have a sense of by how much?
Twice.
Yeah, I mean, is what you're saying that you could actually like rotate once here, then twice here? Is that what you mean by twice?
Maybe. So if we multiplied by negative I twice, it might result in the same thing.
Yeah. What about W? Let's pause for, or should we go back to I? What about W?
Don't know.
Between 180 degrees and 270? No, 270 and I don't know.
But what if we multiply B by negative I, or sorry.
Wait.
Oh, I see. Got it.
B by negative I, wouldn't that just end up here?
Would it end up back here?
What do you mean by B by negative I?
So the coordinates of B by another negative I.
Mm-hmm.
So positive I squared. Negative 1.
Since one touch.
Yeah.
So what happens when you multiply the coordinates by negative 1? Of anything. It just flips over the X and Y axis.
Both axes.
Yeah,
X
I was
equals
gonna
Y.
say both axes.
Well, wait. Yes, but how if what you were saying before, I think, is that you get this rotation, right? Like you're flipping over an axis, but what's really happening is a rotation by 90 degrees, right?
Mhm.
Yes.
And so do you want to end with a conjecture about what might happen with W? Given what you see based on what you plotted?
Half.
It's
I
reasonable
don't know.
conjecture.
I'm
Okay.
still kind of in the middle of.
I'm still wondering why W is actually equal to that.
You're still wondering why W is actually equal to that complex number.
Yeah.
Okay. We're out of time really, but Nantucket, do you want to say anything about why W is equal to that complex number?
We kind of used some, when we went back and we did number 2, I think it was after number 1, we saw that when we got the length of all the sides of that triangle, we got √3 for all of them. So we ended up with thinking it's an equilateral triangle. And when you use like 1/2 and √3/2, those are going to be like your sine and cosine of, or sine of 30 is the 1/2 and the cosine of 30 is the √3/2.
Mm.
Or looking at the 60-degree pieces.
Yeah.
So we were thinking the W, since it took 3 rotations to get around the triangle using W in number 2, we thought that maybe there'd be a 120-degree rotation, taking the 360 and dividing it by the 3 times it takes to get around. So that's what we were hypothesizing.
What do you think about the 3C rotation? How would you describe that?
Yeah, so we think that based on now we came out that like Darren said that it's kind of related to 2, that 3C is rotating 120 because in number 2 we see like all these rotation around the triangle, which is 120. So we hypothesize 3C is also rotating around origin 120 degree.
Mm.
Yeah,
Okay.
Kind of clockwise.
that makes sense with the √3 now. The √3 is
Oh, and do you guys finish completing the square for 1? Or
Yes. Yep.
oh, so you got something like W?
Yes. We got W and then the conjugate.
Okay.
Right? Yep. The conjugate.
So I think it is okay.
Why do you have?
Oh, are you guys still good going for another minute? I don't want to keep people because it's 6:33. Just so you know. Okay, Nantucket.
No, we can wrap up.
Yeah, we can wrap.
Okay, let's leave this in the world of conjecture. All right, for now. We'll come back to this. So why don't, Ton, can you bring, and Yuan, can you bring this same problem set with you next time?
Yep.
Yeah.
Okay, because I think we don't, just to make sure that these 3 are done, I think is worth it.
Okay.
So we'll move from conjecture to some confidence next time. Okay.
Yeah.
Okay. Thanks, everybody.
Thank you. Have a good night. Have a good
Vacation. We're going out for vacation.
Oh, good. Okay. Bye.
Bye.
Because it's usually